Erik, thanks very much for sparing us some time here at EU PVSec. Lots of companies talk about cost reduction, high efficiencies, looking at roadmaps, but there's something that you're doing a little bit different. You're looking at things from an industry perspective a little bit differently. Could you give us a good understanding of what you exactly mean by life cycle analysis?
Yes, REC is of course working on cost roadmaps and improving our products as well. But life cycle analysis is an analysis of the environmental impact of a product through its manufacturing chain and into its life cycle and into its recycling phase.
How do you work that out? What's the ingredients you have to look at, the data that has to compile this?
Yeah, so obviously when the PV module is producing solar energy, there is not many emissions at all. So it's typically our manufacturing chain that we're looking at. So what are the consumption materials, what are our emissions, and so on.
Now, obviously, is this an advantage to you because you obviously the first fully integrated module manufacturer because you've got your own polysilicon, you've got everything going. So does that give you the ability to do this very, very accurately?
Yeah, I think we have better insight than almost everyone else in that value chain. And obviously for a crystalline silicon module there are not many dangerous or toxic materials, so it's very much about energy consumption. And the energy consumption in a crystalline module is quite high. And we identified that as a big cost element a long time ago and started the development of the FBR process to basically take down the energy intensity of our crystalline product, and that also greatly improves the environmental impact.
Right, so you're getting a double hit from this. You're focusing on the environmental side, but it's actually driving down manufacturing costs at the same time.
Yeah, both are pulling in the same direction.
Well then, you've explained that side of it, but there's also another aspect here that you've worked on, and I wanted again to get a better understanding is what you really mean by energy payback time.
Yeah, so if you go far back, actually a solar module would spend maybe 10 years to regenerate the energy that went into making the module. So you could say it was renewable energy, but it was hardly giving a positive contribution. Now over the last 5 years that's helped a lot. So the typical numbers are 1.5 or 2 years at the moment before a module has regenerated its energy. And when we are now are launching 1 year energy payback time with a new FBR process and a lot of downstream developments, that's a big contributor both on our cost side but also to society.
Now, is this in comparison to other companies' crystalline product that you've actually got a very, very low energy payback time, or is this an industry thing that there's a wide range of energy payback times?
There's a quite wide range, but I think the majority of the players are between 1.5 and 2 years. And,
so you feel this is a competitive advantage then, that you've got something so one of the lowest energy payback times?
Yeah, clearly. And when the industry is growing by 100%, actually if you then have a 2-year payback time, the industry itself is a net consumer of energy every year. It's not delivering anything to society. But when you're down to a 1-year payback time, actually the solar industry can deliver net power.
So I'm assuming that you're seeing this as a benefit to the customer. What areas does this also play a part in?
It plays a part for the customer, but also for of course the policymakers who will, when you have so low energy payback times, get real net power added to their society. And it also helps our cost structure going forward. If you believe in higher energy prices, then of course this energy payback time will become more important.
So I'm assuming then, with your life cycle analysis done, your energy payback time analysis done, you surely must know the actual carbon footprint of your products. Can you give us an idea what you feel that is?
Yeah, so since we have a lot of hydropower in addition in our manufacturing process, we are extremely low in the carbon footprint, down to about 21 gram or 20 gram per kilowatt hour. and that's in comparison, for example, to coal power at 900 grams per kilowatt hour.
Well, Erik, a final question for you. Combining all of what you've said together, where does this matter? Is this going to be something that others are going to have to adopt? Is this a mere marketing ploy?
I think it's something that people want to adopt because you want to lower the energy consumption and your energy costs. It's not something that everybody will be able to adopt because it's especially the FBR process is a tricky process. But it's definitely a parameter that the complete industry has been working on.